Here we are given with a situation where a man has to cross a river. He can do so in two ways. First, to cross the river in the shortest path. Second way is to cross the river in the shortest time. What is the meaning of shortest path? Let us say man is starting here. If he is starting here directly opposite to the initial point, this is the initial point or the starting point. Directly opposite to this, he has to reach. That will be the shortest path. Are you following something? He has to cross the river in two conditions. One is to cross the river in the shortest path. Second is to cross the river in the shortest time. In this case, we are discussing if he has to cross the river in the shortest path, means wherever he is starting, exactly opposite to that he has to reach. Final point should be exactly opposite to the initial point. So here we can say that this D, which is given, D is nothing but the width of the river. D is what? Width of the river stream. We can consider U as the speed of the water stream. U as the speed of what? Water stream. And that we can assume that the river is flowing in this direction. This is the speed of the water stream. V is the speed of the man or the boat in still water. Speed of the man or the boat in still water. Or we can tell that V is the speed of the man with respect to water. V is the speed of the man. Now, how he has to row his boat so that he can directly reach exactly opposite to the initial point? Let us say, suppose for example, if he is making his strokes in this direction, this is the speed of the man, isn't it? V is what? V is the speed of the man with respect to the water stream. So if he is making his strokes in this direction, not only his speed, but speed of the river is also there, which will add up to his speed. So the speed of the water is in this direction, and the speed of the water is in this direction, and this is the speed of the man. So therefore, these are nothing but two vectors. As you can see clearly, this is the speed of the man with respect to the water, and this is the speed of the water stream. So what will happen? These are like two sides of a triangle taken in the same order, two vectors represented by two sides of a triangle taken in the same order. The resultant is given by the third side of the triangle taken in the opposite order. So resultant is given by the third side taken in the opposite order. This is the resultant speed. So ultimately what will happen? Ultimately he will reach here. So this cannot be the shortest path. So I was just thinking, if he is making his strokes in this direction, if he is correct, if he is moving in this direction, if this is the speed of the man with respect to the water, then the resultant of his speed, correct, and the water speed will push him to go in this direction. Ultimately, he will reach here. But what was our condition? Our condition was that he has to cross the river in the shortest path. Wherever he is starting, he has to directly reach there. So it cannot be achieved by this condition. So this diagram is wrong. Then how he has to row? Let us say, let him row in a certain direction. Let us say making an angle theta, making an angle theta with the vertical. Let us say he is making his strokes in this direction at an angle theta with respect to the vertical. So what will happen? His speed is there, correct, with respect to the water, and this is the speed of the water stream. So the resultant of this and this. So these are like two sides of a triangle taken in the same order. These are like two sides of a triangle taken in the same order. So the resultant of this and this will be pushing him to go in this direction, isn't it? Will push him to go in this direction. So the resultant of the two speeds is given by the third side of the triangle taken in the opposite order. This is my resultant speed. So if he is starting here, so the resultant of this and this will push him to go in this direction, and ultimately he will reach here. So wherever he started, ultimately his final point also will be exactly opposite to the initial point. This is what I wanted. And D is the width of the river stream. Now, therefore, this diagram is right. Now here what we can do, we can apply the Pythagoras theorem. We can calculate the resultant speed. What is VR here? VR is nothing but the resultant speed. So how do we calculate the resultant speed? We can apply the Pythagoras theorem here. So what is the Pythagoras theorem? Pythagoras theorem is VR square is equal to U square plus V square. So this implies VR is equal to root of V square plus U square. This is the resultant speed, first point. Second point is time taken by the man to cross the river. Second point is time taken by the man to cross the river. How much will be the time taken by the man to cross the river? when we are applying here, there are no accelerations involved, isn't it? Here there are no accelerations involved at all, only constant speed is there. So we can easily use the equation velocity equal to displacement by time, because there is no acceleration involved. We need not have to use the kinematic equation, but you have to remember velocity is a vector and displacement is also a vector. So this implies what? Time is equal to displacement by velocity. But keep in mind that when you are using this equation, displacement and velocity must be in the same direction because they are vectors. Displacement, you have to be very careful that displacement and velocity must be what? Must be in same direction. We have used this point many places, in many problems we have used this point. Distance and velocity must be in the displacement and velocity must be in the same direction. So here, if he has to cross the river, then how much distance he has to travel? What is his displacement? Displacement is d. As you can check out in the diagram, displacement is what? Displacement is d. And what is the velocity which is in the direction of d? V and u are not in the direction of d, only vr is in the direction of d. You can see d is vertical, vr also is vertical. So you need to take that velocity which is in the direction of what? Which is in the direction of d, because they are vectors, you cannot just use like that. So therefore, what will be the equation for time? Time is displacement is d, and the velocity in the direction of displacement, that is d, is nothing but vr. I'm not telling that because vr is the resultant speed and we have to take the resultant speed. No, it's not that. We have to take that velocity which is in the direction of d. And third point is angle made by the man or the boat with respect to the water stream. So how much angle the boat has to make with respect to the water stream? Here also many will do a mistake. Many will go wrong here telling that. So that is, I have to find the angle made by the man. That is speed of the man with respect to the water is v, and u is the speed of the river stream. So they'll be thinking that I have to find this angle. So they'll jump to a conclusion that this is theta, this is 90, and the angle between the velocity of the man with respect to the water and the water stream is 90 minus theta. They will tell this as the angle. No, be very careful. Angle between two vectors is nothing but the angle made by the intersection point of the two tails or the intersection point of two heads, isn't it? So this is not the angle between v and u. This is not the angle between v and u, because head of v is coinciding with the tail of u. Then what will you do? You will either make the heads of the two coincide, or you'll make the tails of the two vectors to coincide. So take this u vector and shift it over here. Just take the u vector and shift it over here. I'm just taking this u vector and shifting it over here so that the tail of v and the tail of u will coincide. So what is the angle between v and u? The angle between v and u is nothing but 90 degree plus theta. It's not 90 minus theta. So angle made by the man or the boat with respect to the water stream is nothing but 90 degree plus theta. You can find theta using some trigonometric function, like you can apply, say, sine theta. You can apply sine theta is equal to opposite by hypotenuse, u divided by v, or you can apply cos theta. Cos theta is adjacent by hypotenuse, which is vr by v, or you can also apply tan function. Tan theta is equal to opposite by adjacent. You can apply any of these three trigonometric functions and you can calculate theta, and therefore the angle made by the man with respect to the water stream will be equal to 90 plus theta.